Okay, for Form 1 notes and books, I will just selectively take some important parts to take record. For example, this page 0.9, okay, multiple and factors, and quick quiz. Find the first 4 multiples of the following numbers. For example, 8, okay, 8, and then next multiple is 16, and then 24, and 32. Okay, for 15, 30, 45, and 60. Okay, this is the quick quiz first one. The second one, find all factors of the following numbers, 16 and 42. 16 is 1 times 16, is 2 times 8, is 4 times 4. So the factors are 1, 2, 4, 8, and 16. For 42, okay, 42, 1 times 42, and then it is an even number, and this can be divisible by 3. 4 plus 2 is 6, is the multiple of 3, so 3 times 14. Okay, and then it is 6 times 7, and that's it. 6 and 7. Okay, so 1, 2, 3, 6, 7, this 8 factors. 1, 2, 3, 6, 7, 14, 21, and 42. Okay, so these are factors. So goes on prime numbers and prime factors. Okay, if there's a prime number and it's also factors, then it's prime factors. So I can express the thing as a product of prime factors. For example, express 168. Okay, it divides by prime number successively. 2, 2, 2, 3. Okay, and goes on. All the numbers are prime and then multiply together, prime numbers. Express 3, 2, 4 as a product of prime factors. For example, 3, 2, 4. Okay, instant drill 3, 2, 4. So 3, 2, 4. It divide 2. Divide 2 is 1, and then 6, 2. And divide 2 goes on 2 and 81. 3 and then 27. 3 and then 9. 3 and 3. So 3 to 4 as 2 times 2 times 3 times 3 times 3 times 3. All are prime factors. So, and I use index notation. 2 times 2 is 2 square times 3 times, there 4 times, that means 3 to the power 4. So 3 to 4 will be 2 squared times 3 to the power 4. Okay. So index notation, the square of 7. If 7 times 7, 7 square. 5 times 5 times is cube of 5 to the power 3 is 3 to the power 5. Okay. It goes on. After this method, we can use instead notation. Okay, goes on. This one for exam to express these two numbers as the product of prime factors. Use index notation. Okay, this index notation to express each number as a product. That means multiply together. Prime factors. That means 2, 3, 5, 6, 2, 3, 5, 7, so on. They are prime numbers. So it goes on 36. For 36. Okay, we got 2. We got 2. We got a 3, a 3. So 36 equal to 2 squared, the 2 of 2, and 3 squared. Let's go on to 63. For 63. Get 3, get 3, 3, 3, and 7. So 63 is 3 squared times 7. Okay, so the highest common factor, we are going to study a better methods that can explain what's meant by HCF. Okay, if we express the numbers as the product of prime factors, that means the smallest possible factors except 1. Then 18 will be 2 times 3 times 3. 24 is 2 times 2 times 2 times 3. So what in the common is 2 and 3. The highest thing is, if I multiply together, I take all the things that they are the same, then it will be highest. Okay. For example, 2 times 3 squared times 5 and 3 times 5 times 7. So if we just put the numbers here, they are all prime factors, and we take a common, no common. So 3 and 3 times 3 is 3, just there in front of 3 common. 5, there's 1 of 5 common. So the highest common factor will be take the lowest power of each one and then multiply together, they're 15. So let's do an instant drill. Now find the HCF of 2 squared times 5 and 2 cubed times 7. Okay, 2 squared times 5 and 2 cubed times 7. So the lowest power is common in 2 squared. No common, no common. So the HCF is just 2 squared. That means the HCF is 4. So it's the same way for you to find the highest common factor. Okay, and how about 16, 72, and 150? Let's do it. 60, 72, 150. You may think that this method is very slow. Yes, but I think you should learn this method because this can explain some important concept in factors and numbers. 7 plus 5 is 12, so this is the part of 3. So 3 times 2, 60, 1, 5, and then 5, 5. So 60 is 2 squared times 5 times 3 times 5. 72 is 2 cubed times 3 squared. This one is 2 times 3 times 5 squared. 150 is 2 times 3 times 5 squared. So what they in common is 2, just 1. 3, 1, 2, 1, just 1. 5, no. So the HCF is 2 times 3. That means the HCF is 6.